Each and every particle of photon took almost 8 minutes to reach our Earth from the surface of the Sun. But that's not all. Every particle of photon was produced at the core of the Sun, and it took them almost a billion years to travel from the core to the surface of the Sun. Amazing, isn't it? Continuous nuclear fusion is happening at the core of the Sun. Billions and trillions tons of hydrogen are being converted into helium and then onto heavier elements every second. And this huge amount of energy wants to push out, but the gravity of the Sun is somehow keeping them in check. Every once in a while, this enormous energy in the form of plasma escapes the Sun's gravity and ejected into the outer space. We call this CME, or the Coronal Mass Ejection. And sometimes the Earth is directly in the line of fire. The Sun and its atmosphere has several zones or layers from the inner core to the outer corona. Beyond the corona is the solar wind, which is an outward expansion of coronal plasma that extends well beyond the orbit of Pluto. This entire region of space influenced by the Sun is called heliosphere. Controlled by the Earth's magnetic field, the magnetosphere acts as a shield protecting the planet from solar wind. The shape of the Earth's magnetosphere is the direct result of being impacted by solar wind, compressed on its sunward side and elongated on the night side, the magnetotail. The shock wave where the solar wind encounters Earth's magnetosphere is called the bow shock, which slows and diverts the solar wind. Solar activity leads to solar eruptions, which include such phenomena as sunspots, flares, prominences, and coronal mass ejection that influence space weather or near-Earth environmental conditions. Modern societies depend heavily on a variety of technologies that are susceptible to space weather. CME, for example, can cause geomagnetic storms that can disrupt satellite communications and navigational equipment, and even cause blackouts by burning out the power grid. Sun is temperamental and periodically changes its behavior from low activity to high activity. A new solar cycle comes roughly every 11 years. Over the course of each cycle, the star transitions from relatively calm to active and stormy, and then quiet again. Understanding the Sun's behavior is an important part of life in our solar system. Luckily for us, we have an array of satellites which are keeping a very close eye on Sun and solar weather. The Solar Dynamics Observatory, or SDO, is a NASA mission which has been observing the Sun since it was launched in 11th February 2010. Parker Solar Probe launched in August 2018 to study the Sun's outer atmosphere. At closest approach, the spacecraft will be flying at about 600,000 km per hour, or about 0.064% of speed of light. Parker Solar Probe has already touched the Sun, passing through the Sun's outer atmosphere, the corona, for the first time in April 2021. Closest approach was 8,541,744 km on November 21, 2021. During Parker Solar Probe's 8th orbit around the Sun, the spacecraft flew through the structures in the corona called streamers. This clip shows the data from the WHISPER instrument on Parker Solar Probe. Planet Earth has its own defensive mechanism, the ozone layer. This layer deflects most of the harmful UV rays, but our heavy industrial activity is taking a heavy toll on this protective layer. The best defense Earth has is its geomagnetism. It protects the Earth from the harmful cosmic rays and energetic charged particles from the Sun's CME. Without its protection, Earth will face a catastrophe. All communications will cease to exist. No internet, no phone communication. Those who rely heavily on technology will collapse. Though our magnetosphere does protect us somewhat, but some of the charged particles do get in, especially in the polar region. And this CME manifests itself in spectacular fashion which we know as aurora.
In the next part of video, we will explore how the solar flare can affect the positioning system on Earth. We will explore about atmospheric scintillation that is generated from the geomagnetic storm. So if you are an offshore surveyor, click the next video as this affects your offshore survey position.